Hey guys, Mr. Bowman here. As promised, once I hit 50 subscribers, I was going to do a complicated maths question, and I just thought I'd show you guys. Here's my little bunny rabbit, Toby. I thought he would be a guest feature in our 50 subscriber special. So what I'll do is I'm going to put him down. So if you hear something in the background, it's going to be him running around. All right, and today's video is all going to be about a branch of maths that I've been looking at myself lately. It's to do with complex numbers, which are imaginary numbers that we have made up to solve problems that otherwise would not be able to be solved. So I'm just going to write an example on the screen. An example 18 cis 2.56 times 6 cis negative 1.44. If we were to complete that multiplication, that would become 18 times 6. So what we have to do is we have to multiply the numbers out the front. And cis, because we are multiplying these two functions, we have to add together the functions that sit by the cis. So we have to add together the negative 1.44 and the positive 2.56, and that would come to 108 cis 1.12. So that would be the product of those two. So what I want us to do is I just want to mathematically prove that the front becomes a multiplication and that the middle becomes a addition. So what I'm going to do is I'm just going to get rid of the work that we just did, and we're just going to put it in a more general form where we are dealing with variables instead of exact numbers. That means if we can get that to prove, that means it doesn't matter what the numbers are, the maths would follow as well. So I'm just going to change the blue pen because it is my favorite one. And what I mean by that is I am looking to prove that so R would have been the number out front of the cis, cis A times R2 cis B. And just so you guys know, that multiplication sign is in the middle, but those two dots on either side of that are also multiplication as well. So we're trying to prove that that would be equal to R1 times R2. So that was the two numbers out front multiplying each other, times cis A plus B, and the A and the B, they related to those numbers, the 2.56 and the negative 1.44 that sat within the brackets. So that's our goal. So I'm going to write that second part down the bottom because that's what we're trying to achieve. We're trying to get our equation to look like that. So let's write that bigger and up here. So we're trying to manipulate or change our left-hand side, which is this part, so it ends up in that form there. So let's quickly erase that part there. And below that, I'm going to start my manipulation. So the first thing that I wanted us to do was I'm looking to change the cis parts of these into the expanded or bigger form. So what that means is, so cis A actually means cosine A plus I, oh, that more looks like a T, plus I of sine A. And then we can see that cis, so the C comes from there, the I there, and the S there. So we're just going to change the form of our thing. So that would be R1 times, how about we put that in brackets, R1 times cos A plus I sine A. And that's going to be times by R2, and we're going to change those also to be cos B plus I sine B. So that's our first step. We've used this little trick and we've changed the form of it. So I'm now going to get rid of that so I've got more room to work, because I am anticipating needing a lot of room to finish this proof. The next step, what we're going to be doing is we're just going to be rearranging the form of our equation. So we can see everything is multiplication. So what we're going to do is we're going to move this R2 to the front. So it's going to be R1 times R2. And straight away, looking at our final end product, our goal, we've got that down there. Okay, and we're then going to put or leave our brackets there. So that's cosine A plus I sine B, and then in the second bracket, cosine B plus I sine B. And I've just realized I've made a mistake in that first bracket. So let's get rid of that B and let's change that to an A, because that should be an A. Okay, so the step after this is we are looking to expand this double bracket just like we would expand a quadratic. So let's do R1 times R2. So that hasn't changed. And we're going to do the first one times the first one of the second bracket. So that's going to be cosine A cosine B. We're then going to do cosine A times the second bit of that bracket. So that would be cosine A times I sine B. We're then going to do the first term in the second bracket multiplied. So the second term in the first bracket multiplied by both of the terms in the second bracket. So that's I sine B cosine B, and then finally I sine A times I sine B. There we are. So that's a big long mess, isn't it? Okay, and the next step is to specifically deal with that last part in blue. So I sine A times I sine B. And what we need to know there is some complex numbers rules. So just that part there. And just some things to note on the side. I times I becomes I squared. And I squared is equal to -1. So we're going to change that portion to negative sine A times sine B. So that's now the negative version of itself. And at this point, I'm just going to do a bit of rearranging. I'm going to move the things with the i's left over to one side, and I'm going to move the things without an I in it to the other side. And that'll help me with factorizing, which is quite a useful skill in this example. So R1 times R2, that is going to be multiplied by cosine A times cosine B minus, so I'm going to move this sine A sine B function there, minus sine A times sine B. And then the two things left with the I, I'm going to move the I out front. So I'm going to go plus I. And I'm actually going to factorize and take that common I out. So the first part, that's going to leave cosine. Actually, let's use square brackets here. That's going to leave cosine A sine B. So that's factorized. That term, we're going to factorize the rest. We've got a sine B and a cosine B as well. So plus sine B and cosine B there. Cool. And just noting, I have made a silly expanding mistake earlier. So just going to modify my answer to that. So of course, both of those would have been A because we are timesing them by the I sine A. So made that update. And then going to close our bracket. And then we're going to put a big bracket around the end. So we've factorized that little bit there, and that's a really important step. And there's two other rules at this point in time that we need to be aware of. So the first one is cosine A plus B. That is going to be equal to cosine A times cosine B minus sine A times sine B. And if you have a look at our equation, we've actually got that there. We've got a cosine A times cosine B minus a cosine of minus a sine A times sine B. And the other part I want to draw our attention to is another one of these formulas, the sine equivalent. So sine A plus B, that is always equal to sine A times cosine B plus the opposites of those, cosine A and sine B. And if you have a look at the last part, or our square bracket part, they are in the wrong order, but we've got a cosine A sine B to start off with, and then a sine A and a cosine B after that. So what that means is we're going to actually change the form of this part and this part here based on those formulas. And I'm going to do that below. I'm just going to switch back to my blue pen to carry on with my working. Okay, so we're going to do R1 times R2 times, so that first part, that becomes cosine, and in brackets A plus B. So cosine A plus B. Okay, and then after that, so I'm just going to put those in square brackets. After that, we're then going to add I, and that's where that's from, and we're going to times that by sine AB, which the second part comes to. So let's do that. That's going to become sine A plus B, and a square bracket to finish that part off. And what I'm going to do is I'm quickly going to get rid of that working on the, oh no, actually we'll leave it there. And at this point here, I'm going to switch back to our orange pen. The formula that we looked at before, cis A, what that was equal to, that was equal to cos A times, plus I sine A. And if we have a look at that underlined part, we do have a very similar form there. We've got the cosine element there, so cosine's up there. Instead of A, it is A plus B, and we've got the I sine there as well. So what we're going to do is we're going to change that underlined part to cis A plus B. So it's R1 times R2 times cis A plus B. And let's put that in brackets. And what we've done there, that's our final step. That's actually our proof that R1, so let me change to a different color pen. That's our proof that R1 times cis A times R2 times cis B was equal to R1 times R2 times cis, and then in brackets A plus B. And if you remember, what we did is we shifted our answer to this side before, and you'll see that perfectly matches up with our end result, or our proof that those two are equal to each other. So hopefully you guys found this 50 subscriber video cool. This is a branch of maths that I really enjoy myself, and hopefully you did enjoy seeing Toby, my bunny. And when we double the subscriber count, so when we get to 100, we'll do something else. The ones that people have suggested are doing some Sudoku, opening some Pokemon cards, and some other like real cliche Facebook type events. All right, so thanks for watching, guys, and we'll see you later.